Good afternoon, all. Hopefully you're out there in the ether, all listening in at 3 o'clock for Osmoflo's. I think this is probably, certainly my personal inaugural virtual presentation. So thanks for logging in, those that have joined this afternoon. We're going to present this afternoon for about 20-25 minutes or so, and have a quick chat about some of our rental fleet solutions. For those that haven't had much exposure to Osmoflo's rental business, it's a significant part of our business. We've executed a range of different kinds of rental projects, so we thought it was worthwhile just sharing some of those experiences with you and giving you an idea of what a typical rental solution or a fast track or emergency water project might look like. I'm based in Queensland. My name's Scott Chalmers, and I'll pass over it a little bit later on to George DeCicco, who's based out of our South Australian office in Adelaide, and Ajit Kakani, who's based in Western Australia in our Perth offices. So sort of a little bit of a representation across Australia. Kim, if you can maybe go to the next slide. So for those that haven't had much exposure previously to Osmoflo, we're essentially an independent integrator of predominantly membrane-based technologies, I suppose it would be fair to say. And by the numbers, as it said there, you've been around for almost 30 years, a couple of hundred employees, almost 500 projects have been delivered over that time. And we have around about 118 remote control and operation and maintenance contracts, and that's a pretty significant part of our business. Our view is that it's not just about obviously delivering projects, or in this case, rental projects. It's then about operating and maintaining those assets once they're in the field, and that's really where a lot of the value of water treatment experience comes into play. And we also have some fully financed, around about 8 build, own and operate projects in operation across the country. The business is really, it's got several pillars. Fundamentally, we are based around a business that's based on innovative and advanced technologies, typically membrane technologies, and we often get involved in designing and developing solutions for difficult to treat waters. Sometimes they're a full turnkey project, sometimes they're international, but our home base is in Australia, that's fair to say, and the majority of our projects to date have been delivered within Australia. And O&M obviously is another big part of our business and a separate business unit. But the rental water systems part of our business is what we're talking about here today. Many people think that is how you deliver a rental, and whilst that is sometimes correct, and it is nice to think of all rental solutions as essentially put a container on a truck and deliver it to site and plug it in and away you go. And sometimes it can nearly be as simple as that, but there's typically a little bit more in a rental project than I think sometimes people expect. But that is a deployment of some rental assets to a project. I think that was up in the Northwest Shelf, up in that area in Australia. So containerisation, of course, does lend itself well to a high degree of preparation before mobilising to site, and a fair bit of testing can be done prior to site, and of course sometimes deploying them to fairly arid or remote regions, particularly in Australia. It can be useful to have essentially their own weather protection for the process equipment. So how do we deliver a typical rental project? Will go something like this. There'll be a call or an inquiry made from a client, and there needs to be a stop and hold whilst we understand what the true needs and the drivers of the project are. It is never one size fits all. There always need to be, to a degree, customised for the application, and that's not just the water chemistry itself. It's also some of the site specific and the overall objectives of the client, and it depends what kind of industry you're in. And depends on, I guess, on the criticality of the application and some of the downstream users. So there's quite a few things to try to understand, and any obviously logistical constraints or timing constraints of the project. We'll then usually work internally with our process engineers and operation and maintenance representatives internally to come up with what we believe to be an optimal solution. Now I say optimal solution because it's true to say that in the rental business, it is a case of if the requirement is for fast tracked and fairly urgent requirement, then it has to be based on what assets we currently have available. And we have assets essentially coming and going all the time, all over Australia, that are deployed and then may not be available in the next few months. So we always are mindful of trying to use what assets we have available and basing a process design around assets that are in hand. Once a commitment from the client has been received, there'll then usually be a mobilisation phase where we'll prepare the plant for dispatch, do some factory acceptance testing, and at the same time, there's usually a discussion with the client about the site preparation, because it's better to obviously get some of those works done in parallel. So if there's additional tankage, if there's other ponds, infrastructure, sometimes power has to be brought in, water nearly always has to be piped in and potentially taken away. So there's usually a degree of site works that happens, and we can work with the client or advise, or in some cases do it on their behalf. But usually, if it's an urgent requirement, that will need to be done in parallel to the plant preparation. Once the plant is dispatched, is then obviously installed, and it can be usually put down on, if it's a containerised system, on some concrete sleepers. And you can see an example there. That's one at a Central Queensland coal seam gas customer, where it was laid down on concrete sleepers, in this case with some shade between the two primary process units. And that can be done again by the client, by Osmoflo, or potentially both. And then after commissioning, we're into an ongoing operation and maintenance phase, of which they will normally have some degree of support from Osmoflo, whether that's just chemicals and consumable materials, or whether it's full operational responsibility, like that's discussed earlier in the project. And at the end of the term, clearly there's a decommission or deconstruct the site in some cases, and demobilising them and then returning to Osmoflo's offices in South Australia. So they're the typical, I guess, some of the industries that we've traditionally gotten involved with. Obviously mining, oil and gas, coal seam gas, power generation, food and beverage and municipal. They would cover the vast majority of clients where we deploy these assets, but they can be for a range of application. Sometimes it's just a short-term emergency water need because they're running short, and it's an alternative source that they've located that they need treatment technology for. Or it could be to dewater, particularly in mining applications. It could be to dewater a particular pit and discharge that to the environment at a high quality, and they've got a license for that discharge requirements. Or it could be in a power station situation. It could be a temporary shutdown or for maintenance of a turbine, and they need to have a volume of water in a cooling tower system or other, a variety of different applications. Sometimes in municipal context, of course, it's just a short-term water quality problem that drives them to add in some temporary processes to help them with quality downstream. One of the difficulties of a rental business is the different configurations and the requests and the inquiries come in, both from a capacity perspective. So you can have some quite small applications right through to some very large applications. Obviously, all come with potential challenges. The skids or the containers that we apply, they can be in either. Typically, if they're smaller, they'll generally be containerised up to perhaps a few megalitres a day is almost always containerised. But as they get bigger, in some cases, there is a need to put them onto skids. And in some cases, we actually have used skids in between containers, similar to that photo a couple of slides ago. The process units that we've got essentially available, ready for deployment, include traditional desalination plants, whether that's in a seawater RO configuration, brackish water, or in some cases, nanofiltration, a range of pre-treatment technologies, including membrane filtration, either micro or ultrafiltration, multimedia filters, activated carbon, and big cartridge filter systems. In some cases, post-treatment is needed in the form of chemical dosing, potentially for pH adjustment, etc., and or remineralisation. And in some cases, straight demineralisation via ion exchange. All those systems and assets available in our fleet for all those different applications. There's a shot of the inside of one of the larger ultrafiltration containers. Say they have potential capacity between 50 cubic metres a day and 150 megalitres a day. They typically, as I say, are containerised, but the larger systems are skidded, and they're plug and play as much as practical so that we can rapidly deploy them and set them up on site. And most of those systems have remote monitoring capability, so we can either monitor the system remotely and or potentially help the client with operations, particularly after hours in some cases. There's a larger multimedia installation that was up on central Queensland. From memory, that was about 10 or 12 megalitres a day, I believe that flow was, so a reasonable requirement for filtration, only temporary. Again, can be some quite small flows through to quite large flows, but it is an option if membrane filtration is not required. In some cases, just gross solids removal is required, and either cartridges and or multimedia vessels in that case could be utilised from the fleet. But I guess by far and away, the most of the inquiries we see tend to revolve around a reverse osmosis process solution. And as I say, that can be either seawater or it could be brackish water. We also have some high pressure brackish water assets that have been modified to handle sort of higher salinities that sit sort of in that mid-range between standard bore, low brackish and a high brackish, so maybe sort of 10 to 15,000 parts per million TDS. Nanofiltration in some cases can be used, but they're not as common, those assets or those applications in my experience. And some quite small. I think we have one quite small 10 cubic metre a day system right through to some very large capacity systems, many millions of litres per day. And again, containerised, skid mounted, and obviously designed to be as much as practical, rapid deployment, plug and play concept. And the top photo there actually is a small seawater plant for a remote Aboriginal community up in Torres Strait Islands and between Australia and New Guinea. So that's a fairly classic sort of temporary setup for a rental project. So as I say, they are always designed for rapid deployment because in some cases, particularly the emergency ones, like we had some during the recent bushfires in Australia, where assets or existing infrastructure had been destroyed, we were able to mobilise within a day or a couple of days some substantial treatment systems, and hence the benefit of containerisation. Essentially, that is all done in Adelaide, just about half an hour north of Adelaide, in Burton. In addition to that, that's our head office where we have engineering and project management services, and the commissioning engineers and the operational control centre is all based at that same facility. So we have all the available in-house resources for that deployment to get the assets into the field. But as we noted previously, part of the job is to deploy, then commission and maintain and operate for the term, which can range between anything between 1 month and several years. We have regional operational centres in all major states in Australia and internationally, where we hold a significant amount of spare parts, chemicals and consumables, but also the regional service technicians are located, and then they can work with the clients and do some of the remote monitoring. At the bottom there, you can see the control centre in Adelaide, where we monitor, as I say, about 112 different sites by a variety of SCADA platforms, including our own called Plant Connect, which is our 24/7 facility, quite a unique support vehicle and quite a cost-effective one for these temporary requirements, because typically the clients may have limited either experience or really in some cases desire to operate and maintain water treatment assets if it's truly a temporary need. So there's obviously a heavy safety focus on all these sites, and temporary doesn't mean that doesn't need to be considered. In fact, probably more so the reverse is true, that you still need to consider all the safety requirements of the site, particularly in mine sites and some of the hazardous environments that we operate within. And we have, as I say, in the regions, there is that operation and maintenance resources and expertise, and they're supported by head office process engineering support and the control centre to make sure that the assets will not just work for the first week, but over the term, reliably over the term of the rental. That photo on the right-hand side, apart from being, sorry, Kim, sorry, apart from being a lovely colour, which is the main reason I like that slide, was a particularly difficult feed water at an abandoned tin mine site up in North Queensland. You can see by the colour of the water. But again, that's a fairly typical installation. You can see there's the suction inlet system feeding the plant. You can see the process containers and tankage required there. And discharge was an environmental discharge over the wall on the left-hand side of the shot. But that's not a uncommon kind of configuration and setup. So I'll pass over to George in South Australia for a bit of explanation about the work we did for Broken Hill.
Thanks, Scott. Welcome, everyone. I guess this was an interesting project that we delivered for Broken Hill community. So Broken Hill's in Western New South Wales, a fairly remote location, having severe drought towards the later half of 2015. They were running out of water source options, so then had to make some changes in their sources, which all resulted in forecasting a higher salinity, and with the drought that made matters even worse for that period. So the client then had to look at other options for their water treatment. It was the existing treatment plant at Broken Hill consists of a clarifier and multimedia filter with UV and chlorine, which is quite common across Australia for most conventional sort of water treatment systems. One of the interesting factors that they had applied at this site is the limitation on brine. They basically had a limitation of taking up to about 2 megalitres a day of brine, but despite that have up to 13 megalitres a day of community water demand. The existing plant that was on the site was supplied by Osmoflo back in 2005. And it was a 4 by 1.5, so 6 megalitres a day, comprising cartridge filter and BWRO to supplement the existing treatment plant. It was a 75% recovery design plant, so it was not necessarily going to achieve all the objectives as stated above in those challenges. So we needed to come in and support with additional equipment. Go to the next slide, Kim. Yeah. This, as you can see in the bottom left-hand corner, there's the plant that was actually installed in its entirety. The 4 or 5 containers that are near that shed on the site were brackish water RO treatment plants, and then the 2 containers with a tank in between there were seawater RO plants that were designed to take the recovery higher. One of the key things about this project was the nature of the delivery. It needed to be reasonably quick in the context of the size and magnitude and complexity of the project. So ultimately supplied, designed, fabricated some of the equipment, tested that equipment in our factory, and delivered it to site and installed it and commissioned it within a 12-week period. So it was definitely a fast pace for an overall delivery. One of the things was being able to achieve that 90% recovery. So we used those seawater assets, which were modified to be able to achieve that high recovery overall. And it required some refurbishment of those original plant assets. And one of the key things that made this application success was our ability to remotely monitor and control that plant, as well as the fact that we had the assets available in our rental fleet at the time that they were needed. And that control center support was also supported on site during the day, but during the day shift with on-site operational support for a period of a few months. And then actually the client's site personnel became more and more familiar with the plant and were taking on more and more responsibility as time went on. So yeah, that was a very interesting application that we got involved with, and that plant since then, the rental assets, which comprised of some brackish water and the seawater assets, have been demobilised off the site, leaving the original plant there for the future. So I'll just pass it on to Ajit now, who will discuss about another case study that we had for a project in Mount Marion in the Kalgoorlie region in WA. Thanks, Ajit.
Thanks, George. Hello, everyone. Good morning, good afternoon, depending on which part of the world you are based in. Today, I would like to share some information about one of the exciting and challenging rental project we have been involved with. This is for a lithium mine site in Goldfields region of WA for Mineral Resources, CSIMT MARION. They needed urgent water treatment plant to continue their process operation. They had existing water treatment plant on site, which was struggling, and they had a lot of issues with algae and solids in the water. They needed 3 megaliter UFC water RO plant, and part of the solution what we offered them, it included 6 by 40 foot container, 2 by 20 foot container, along with number of skids for BOP such as self-cleaning screen filter, high flow cartridge filters, and low pressure feed pumps and distribution board, etc. Now, to mobilize the plant, we promised client within 5 days plant will be ready with FAT done in our factory and ready for collection. And the plant was collected from our facility within the 5 days of the order. It was delivered to site within 8 days, and client wanted to have it installed and commissioned and operated as soon as possible. We offer them site installation supervisor to direct their services contractor for mechanical, electrical, and civil installation of the plant. Plant was installed, and then we offered our commissioning team to continue on 24/7 commissioning work, and it was successfully commissioned and was put into production within 28 days since we delivered the plant. This was sort of offered as a plug and play design for the fast track setup on site, and so client doesn't have to do a lot of work on site. It was easy to install on site. In addition to that, we provided 24/7 operators as well, and also we had a 24/7 remote monitoring support through our control room as well. Initially, this project was delivered for 6 months rental only, and when we started the rental plant, as you can see in the top picture, the ghost crib where we were taking the feed water from, you can see from the color full of algae, and TDS was around 24,000. Rental was extended beyond initial 6 months and end of first year period. You can see the bottom picture where bottom half where you see sort of a white grayish area that's pretty much empty, and it's only a little bit of water left with about 39,000 TDS. Plant continued to operate for around 2.5 years, and by the time we finished the job, we were operating this plant on about 45,000 TDS of water. So it was quite challenging, and our process team was always working with client to improve the performance of the plant and give them the continuity of water supply. Now I will hand over back to Scott to continue.
Thanks, Ajit. The significant project that I was involved with in Queensland, up in Mount Isa, for those that are based in this part of the world will know of it. Industrial mining town, fundamentally with a population of about 24,000. Their water supply predominantly comes from a Lake Mundara, it's called, and they have what they call a clear water lagoon and a reed bed filtration system. So it's essentially a natural system that does partially clarify the water prior to putting it in chlorination and into the network to feed the population, and also the refinery, what used to be called Mount Isa Mines, now owned by Xstrata or Glencore. So they had a problem, if you can go to the next slide, Kim, a few years ago, where, and you can see in that picture there, the fundamentally water quality was deteriorating, as was their supply in Lake Mundara. And this was late 2013, so a few years ago now. But it was really driven by sort of drought, increasingly scarce supply, I suppose, and leading to poor water quality and algal blooms that then, after chlorination and the subsequent disinfection byproducts that were present in the water, was causing the water to go out of specification and starting to become a problem from a public health perspective. So they really needed to act to do something on an emergency basis and a temporary nature. And that was the need that was identified. The challenge was really around essentially the high algal content of the feed water. As I say, that natural reed bed filtration system really wasn't able to do any significant reducing of the algal load, and quite high TSS and turbidity levels in some cases. Soluble materials, not a problem in this case, so it wasn't an RO desalination requirement. It was very much a high quality filtration or algae removal application. So the solution was essentially to deploy the majority of what we had locally available at the time, which consisted of a range of different rental assets, all containerized in this case, all either micro and ultra filtration systems that had ability to remove the algae that was required in a different configuration. So there was 3 2.4 meg assets, one 1.4, one 1.2, and 2 much larger 2.5 megaliter a day containers that were all deployed essentially in 2 phases of work in a fast-tracked environment between Osmoflo and the Mount Isa Water Board. So I think I received the inquiry a little bit before that. There was actually a site visit. We met with the client actually on the site to talk about the logistics and essentially also the location, where they had power, where the water was coming from, where the water was going to try to minimise the overall cost of the project, the temporary project. We signed an agreement with them in late 2013. As I say, we had to mobilise phase 1, we called phase 1 part of the project was mobilised within 3 to 4 weeks. And that was the smaller capacity systems were mobilised first, whilst we then had to do some further modification and mobilisation of the larger capacity systems, which happened about a month later. And then by late December, we had the full 20 megalitres a day operational, and you can see that in the bottom photo, all the different containers lined up in a row. We also had a balance of plant is something that a lot of people don't fully appreciate or contemplate, I suspect, when they first do a rental project. And you can see that there's sort of a large panel tank there above the 7 weeks spot. That was, I think it was about a 2 megaliter tank, I think, that we had available from a previous project. So a panel tank with a bladder that was able to be mobilised and installed along with the interconnecting pipework and transfer pumps, which Mount Isa Water Board were responsible for. And that's just a classic shot that I've often used to just demonstrate, and as you would expect, that's a sort of improvement of turbidity and water quality that membrane filtration will provide, which is exactly what the client was after, so they could then chlorinate without the fear of disinfection byproducts contaminating the treated water. We ran that plant for, I think it was on rent for over a year. In reality, they ultimately bought some of the assets, and we replaced some of the assets with some other new assets. Ultimately, they've expanded it to 25 megalitres a day, and that's still operational at Mount Isa. And during that time, though, and the rental period, we did have some, as they continued to run out of, drought really kicked in, and they had some further decreases of availability. They swapped their supply over to alternative supply, which has a propensity for iron and manganese fouling, which in some cases can cause problems with membrane systems. If that material is oxidised and precipitates, it can cause fouling and needs to be considered how to manage it within the membrane systems, particularly ones who are running at what some would consider to be reasonably high fluxes to get maximum capacity out of the system. But we were able to manage that quite well, that iron and manganese fouling. Ultimately, with the right cleaning regimes and the right management of those systems, we were able to maintain good availability and capacity of the systems. And in some cases, we had some spikes of, in some cases, I think there was some data above 5 million cells per mil, in extremely high levels of algae that were able to be dealt with. So it wasn't a case of step back and walk away. We had to continue to support the customer in managing inevitably the challenges under the operational phase. I just wanted to mention for some of our potentially those that are elsewhere or those in Australia that have higher capacity, Osmoflo has access to some large capacity. These ones are seawater desalination plants. We have 4 7 megalitre a day modules that consist of ultrafiltration and seawater RO. So all 4 together have the capacity to, or the capability to produce up to 28 megalitres a day. So, you know, that's a substantial desalination temporary plant for larger, potentially municipal or large mining sites potentially. 2 of these assets or 2 of these modules are currently deployed, but still 2 available. They're currently located in Dubai, in the trade-free zone in Dubai, and they are available for pre-mobilisation inspection. In fact, those shots are both from one such inspection where the plants are set up for available to be as part of the mobilisation and testing phase prior to packing them down. They do come with, or these ones come with the interconnecting pipework and essentially all the ancillaries. So it's a self-sustaining or self-supported process, including the seawater pumps, strainers up front, obviously the ultrafiltration systems, the RO systems with energy recovery devices, cleaning systems, MCC and electrical control, a control room, and the interconnecting pipework, and calcite for remineralisation. So these are large, typically would be a municipal client that could be interested in that for temporary deployment for emergency response. There is a video available. We won't play it here. We've run out of time, but there is a video available, and if you are interested in seeing that, we can send you a link. It's on our YouTube, I believe. But if there are, is George, is there any, I think you might be reviewing questions. Are there any questions?
No, I haven't seen any questions come up, so we'll probably just bring it to a close. I guess if anyone has any questions, by all means, we're willing to respond. So please get them in now if you really want to. Otherwise, we'll bring it to a close, and we'll respond to any questions at a later date.
We're all available for in any of the states or anybody elsewhere. If you can come through either Kim or directly, more than happy to answer any questions offline that you may have. And unless there are some questions, we'll bring it to a close, and we'll thank you for your attendance.